Welcome to the second video of the Foundations of Computational Economics course. This is the practical video. Here we will be installing all the necessary software to set up your local workspace. That includes Jupyter Notebooks, Python, computational environment, the version control system Git, and we'll register on GitHub so that you can access the lecture materials and get assignments. I assume that you have a fairly modern computer. Doesn't matter desktop or laptop. Also doesn't matter whether it runs Windows or Mac or Linux. I will be showing everything on Mac since I'm personally using Mac, but all the software is cross-platform, where you can find analogs of the software that will be needed for different systems. I assume that you will be able to install this software on your computers, so you have administrative access. And let's start with finding your terminal. This is quite useful. A lot of the guides ask you to run commands in the terminal. And overall, some background process can be started from there, and it's quite useful. On Mac, you would find terminal in applications, utilities. Here's my terminal app. And I'm actually using it quite a lot for some background processes. For example, here, a Jupyter Notebook is running on the local server, and this is what allows me to show the slides. On Windows, you would go to Run command under Start button and either run CMD or PowerShell. On Unix, it should be quite obvious. So the main steps of this setup process is to install your Python environment. We will be using, or I would recommend using Environmental Management Manager Anaconda, which includes not only Python, but Jupyter Notebooks as well, and a whole collection of scientific libraries that we will need. Then we will look at installing Git and Git graphical user interface, which makes it a lot more practical to use. Register on GitHub. And last but not the least, having a good text editor is also helpful. It's going to be, we're not going to use it all too much, but generally, a lot of the times it's better to use a nice text editor rather than built-in solutions. I'm putting here a link to CompEcon page on setting up your environment. This is what I'm basing this recommendations on, and this is a very nice lecture there as well, or material. So let's start with Anaconda. This is a collection of software that is useful for running scientific computing. It's based on Python, also has Julia. It includes Jupyter Notebooks, and as I said, a collection of libraries that we will need. Now, they do offer a for-pay service as a company, but we will use the personal individual edition, which is completely open source and free. So you would install Anaconda by going to the download button and installing it in your computer. As you can see, this is cross-platform. You will eventually get something called Anaconda Navigator, which looks like this. But we don't have to use it. We can again rely on the terminal. Let me reset it here. Essentially, after installing Anaconda, you should have a running Python. You can check its version here, and a running Jupyter. So now let's turn to Git and Git GUI. Git is itself the software that implements the version control system, but it only runs on a command line. So graphical user interface makes it a lot more practical. So let me demonstrate. Here in terminal in the command line, I'm in the particular directory. Let's look at the list of files here, and you can notice there is this .git directory, which actually contains all of the information that is needed for this program to work. what happens is that it tracks changes in all of these files, which are called the work directory, and saves incremental changes inside of .git. That makes it very portable. So if you copy this whole thing and then the Git on a different computer or a different implementation of the graphical interface, they will all work with this Git system, with this Git directory. That makes it very useful. So what can you do? You can actually type git help and see how many different commands you have here. But let me just show you one of them. This is a list of changes that happened to this directory and which were saved here. You can see different dates and different short messages explaining what happened in those particular changes. Looking at the graphical interface of the same repository, and here I'm using the source tree, we can see that on the top of the screen you get a similar list of saves, which are called commits, with different commit messages. But then on top of that, you can go through them, and in the bottom section there's a list of changed files, and for each of those changed files there is what's called a diff. This is the description of what lines have been added and removed from the file in that particular change, marked in red and green. Now, if there is a connected repository to the to yours, then this section here shows how the versions, the changes in different repositories correspond to each other, and you can see that the one that is on what's called origin master is now deviating a little bit. Well, we'll get to that later. The other recommended option is GitHub Desktop, and let's install it together just in a second. Now let's talk a little bit about GitHub. GitHub is really a website which is a sort of a social network for the code developers. It is a good place to host code. It's based on Git, but it's something in addition. It's a place to host code. It has different integrations connected to the version control. And the main purpose is to bring people together, to work together on the open source projects which are hosted there. So I think that registering on GitHub makes a lot of sense if you're interested in computational economics. But please be mindful about your personal data. You don't really need to tell them your real name, essentially. So let's see here. Here's my personal page on GitHub, and give some information about you. But here's the main thing. I have some repositories here, which are different projects. And let's look at this one. This one is actually the repository that we just looked at. It's called EGM and DCEGM. That's connected to a paper, and you can have a little bit of a representation of what this code is doing in this Readme file. And here are the files, and you can also see the history. See, there's 17 commits here, which is basically the same history of changes that we saw on my local repository. Now, I would like to try and install the GitHub standard desktop environment for working with them. And for that, let's go to this link here, GitHub Desktop. Installation should be pretty straightforward. Let's download it. I'm on a Mac, as I was saying before. So on Mac, you have to wait for the download. Let me pause it. Once the application has downloaded, I can start it and begin the installation process. And see here, because it is a GitHub application, then we can sign into GitHub. I assume that you've already registered. I guess you can skip this step as well. Well, let me sign into GitHub. Here are my credentials. No, don't submit. Finish. And here's the screen that you're presented with as you start. And you can see on the list here are the list of my repositories, so the repositories which are linked to my account on GitHub. Okay, we'll come back to that later. Actually, there was a step missed where you should, on Mac, copy the application to the applications folder. All right, so we've talked about the Git and Git graphical user interface, which are different things, right? And yet another different thing is GitHub, which is basically a cloud where the code can be stored. By the way, because you're qualified for the student pack, you can apply for that when you register and get some additional possibilities with the system. Okay, finally, let's talk a little bit about text editors. A good text editor is a very good help for coding work on your computer. You can code or write code in other environments like Jupyter Notebook, for example, but for bigger coding projects, I would say that the good text editor is essential. The good choices are Atom, VS Code, Sublime Text, PyCharm, which is a complete IDE for Python, which is an integrated development environment that does everything for you. Here's Python, has a link to GitHub, Visual Studio Code. Both of these are open source and free. Sublime that I'm using here, that's not free, but it's also a very nice text editor. Here I'm actually editing these notes, lectures. Okay, so just to make you aware of this tool as well. A few words about the typical workflow with the version control system that you might have. So if you're just working on a project by yourself, so this is a single user Git workflow, is to create a repository. If it's an existing repository that you want to link to, you then clone. This is the terminology used by Git. Then you actually work in the working directory. You code. You're doing work there, and then you can observe what you've done and compare that with the previously saved version. So you look at diffs, then you stage and commit your newest changes, and then finally you either upload them to the server or share them with a different repository that your co-author is maybe using, or push them to GitHub. So push is another term that is specific to this version control system. And then the cycle goes back. So occasionally you may want to dig back into the history of your changes, of your diffs, if you find something is not working and you would like to see where things went wrong. And you might have to check out your previous versions. Check out means that you take the files from the saved increments, the saved history, and put them into the working directory. Branching is a completely different and separate topic where you create different versions of this history. You branch out the history to work or try out some experimental features or work on versions of the code. Not really needed for the single user workflow. For the work with other people, so multiple co-author use of Git. There are several ways you can do it. So let's look if you want to at the case where you don't want to use GitHub. Then usually each user, each co-author has their own directory and repository which are linked together, and then everybody is doing their own work in their own environment, completely independently of other people. And as before, observes diffs and makes commits and writes into their own history of edits. But then what's in addition, the step that is different is merging work done by different people together. And here branches become important because you don't want to you want to use different versions of your own code when you merge it with other people's code. So you may have a working version and something that you're currently developing, which doesn't have to be merged yet. Now, if GitHub is used in addition to this, then the cloud, the GitHub repository, can serve as a central point where people put all their work in. And then it's important before you start working to fetch the latest version of the common code from the cloud and then merge it into your working directory. And then start working on the codes, commit, make branches, and then send them back to GitHub. Now, the convention here is never to work in the main branch, which is called master, and always create a new branch before pushing it up to the common repository. And then what happens is that something called pull request is created. So this is for the situation where there's a big project and somebody is managing the source code, and you want to help. You write a little additional feature or a little additional function, put it into a different branch, and then push it to your copy of the repository and make a pull request for the main code, main repository to take in your work after it's been checked. I'm not sure we will go through all of the of these functions during the course, but it's good for you to know these possibilities. Okay, now let's do something together as an exercise one. So this is an example of hands-on experience that I will be giving during in this practical videos, and we'll just follow the steps and see how all this works in real life. So number one, create a test repository in GitHub. I'm going to use my own GitHub account, but you should use yours, and I assume that you've done the registration already. So I go here, I click new repository. This is going to be a new repository that I'm creating on GitHub. I think when you register, GitHub offers you to create a new repository immediately. But let me call it tests. And I'll give it a description. Repository, or this Git tracked working directory, is short to repo. And let me make it private. Now, whether you can make private repositories depends on your status on GitHub, and if you've applied for Student Pack, I think then you're able to create private repositories. I'm going to initialize this repository with a Readme file. Here's the thing. Git Ignore allows you to list the types of files that you don't want the repository to remember. This could be temporary files or things like that. For all different languages, there are standard pre-made Git Ignore files. For example, if you're working on, say, a LaTeX project, or tech, I guess, there can be a tech Git Ignore, which doesn't add into your repository any of the temporary files. We don't need any of that. Now, license is an important thing if you're working on the software that would be distributed. Also doesn't apply to us here. Okay, I'm creating the repository, and this happens on the cloud in GitHub. So this repository now only exists in GitHub, and it has a little README file. You can recognize this README file from the description of DCGM paper that we looked before. Here you can present your project. Now, the .md in this README file refers to the Markdown language, which is used to edit this file. And this is a very simple way to put some formatting into a text document. What's next? Edit README file online. That's the next task that we will do. I don't need any of those windows now. How do you add it? And by the way, what's the history of changes now? Well, there's an initial commit made by me, and it's just the beginning, right? Initial commit is the description of this commit. So we can actually edit files online on GitHub with some instruments that are provided. So here's a little button to edit the file. And let me say that this is tests. Well, first of all, maybe I should give it a little bit more detail. Test repository for the CompEcon course. Illustrating the changes made online. All right. Now, saving in the Git system is called commits. You're committing the changes into the history of changes. There must be a description of it. Commits are impossible without a message. And the standard message is updating Readme file. Yeah, let's just leave it update. Now, commit directly to the master branch, which is something that you can do when you're working on this yourself. But as I said, if you're a part of the big project, then you want to always commit into a new branch. So you're creating a new branch with your additional changes and work in that branch for a while before you send this new code to the big project. I'm safe to commit to master, so I commit changes, and that's basically saves what I've just done. And you can see that we have an updated README file here. And in the history now we have second commit, which is an update to the README file. What should we do next? Clone repository to the local machine. So as I said, this repository here only exists on GitHub right now, but we want to work with it locally. So I'll go to my local GUI Git environment, the graphical interface. This is the GitHub Desktop that we just installed, so let me work on this one for now. I have many repositories, so I'll try to search for this new one, and it's obviously not yet here. Is it the right name? Tests. Update. Okay, here we are. Here's my repository tests. And now I want to bring it down to my computer, to my local computer. The way this is done is called cloning. So what's cloning? That's basically cloning a directory or a repository means that I'm creating a copy of that remote repository on the cloud down locally on my computer, and I keep the link to the previous version, to the other repository, which will be locally called origin. So I'll clone this, and here is an important thing is to be aware of where on the local machine this repository will be cloned to. So I'll remember that this is in my documents folder, GitHub tests. That's fine. I'm cloning using a URL, or you can, in this window have other options as well. So now what's happening is that the files are copied from the cloud down to my local repository, and the history of these changes is right here. So we get the whole history of changes in this new cloned repository. The changes in the current files, we don't have any. And then here are the changes that correspond to the two commits which already made. Now, if I want to make changes locally, I have to also open this directory in some editor. And here where Sublime or other text editor comes handy. So where's that repository which we just cloned? Remember, it's in Documents, GitHub, Tests. That's where it is. And in this text editor, I can open the whole directory. So we can see there is only one file in the directory, README. It is a markdown over here in the bottom. You can see the type of the file. And so it's presented in the markdown way. This, for example, means the heading, and it's already made bold. Okay, what's the next step in the exercise? We've cloned the repository to the local machine. Observe the history of changes in the local GUI. We've done that already too. Here's the history of changes that corresponds to the history of changes online. make several changes in the working directory. So how do we do that? Well, I've opened the file in the local editor, so now I'm editing on my own computer. I can edit the README file itself, adding some text locally, and I'll save. And let me actually make a new file, a completely new file. Let me save it under the name of notes, txt. It's going to be saved in the same directory. Some notes made low on the local computer. And I'll save this as well. As you can imagine, any kind of text files can be worked with in this way. LaTeX files, code files in any language. This is really a powerful system in that sense. So we made the several changes. Now we want to commit changes, so saving the changes into the Git repository locally. How do we do that? Well, we go to our graphical interface, and here now we have the changes that are made in these files. See the new line, the green line, and some green line in the file notes. Interestingly, with a good text editor, you would see these changes immediately in the text editor itself, with some additional packages, I guess. So here's the indication for the new line in the Markdown document. Here's the indication. See this green little thing? That's the indication of the green line of the new line that I just created compared to the last commit. Okay, so we need to commit both of these changes, and let's see how it's done. I guess I have to choose which files I want to commit. I want to commit both. And here's the summary of the commit. Commit to master, as we did on the GitHub web interface. So here I say local changes and commit to master. Now, no local changes are currently seen anymore because we've just committed all the changes. But in the history here, we can see that there is a third commit, which we've created locally. Now let's go to GitHub and update this page. You can see that here nothing really changed. We still have 2 commits on the web interface, and that's because this is a completely separate repository. They are linked, but they are not. This one is not updated with the changes made locally here. And this button, the error indicates that there are some changes on this local repository that the server doesn't yet know about. In order to make it know, we push changes to the origin. Remember, origin is that other repository that we've cloned from. And I suppose that's what we need to do in step number 7 of the exercise. So we push changes to the origin. You can see pushing to the origin is happening now. Fetching means receive information from the origin in case there were some changes made over there. And we can, this is like updating the information. That's called fetching. Okay, finally, we should see the changes that we've locally made up on the server. Of course, this is a web interface, so we should update the page. And see, now we have 3 commits and 2 files. The file notes can be seen in the web interface of GitHub as well. So you can see there is 1 line here. And if I go back to the history of commits, we get this local changes commit coming up in the history as well. Okay, we've completed the first simple exercise of working with Git and GitHub. Now, doing your work, committing your work locally, and then pushing your work up to GitHub is going to be the standard way to submit your work for me to check. Again, unless you want to do it in any different form, which I'm sure will be not as streamlined. Committing, using Git committing and pushing changes, this is a standard way the coding community works these days, and this is really well designed. Now, we've only made a very short overview of the functions of this version control system Git. For the social coding functionality of GitHub, there's a lot more that I didn't preview now. There is a whole collection of functions for communications between users. There's functionality provided for code sharing to the general public, like code releases and things like that. Interactions with other developers. The repositories on GitHub can be forked. Pull request is something that I've already mentioned. That's when you want to help some project and submit your work. For code review, which can be then unsuccessful code review pulled or merged into the main code being developed. Now, GitHub also hosts pages online, and that's actually a very nice way to have your own little presence on the web. So this is called GitHub Pages. That's originally made for presenting a project online, but you can make your personal web page that way as well. There's an interactive mini course that Git offers to teach you about the functions of GitHub. This is free, and this is a really fun thing to do in your spare time. But these functions we will not be using in the course. So the course will use the functions that are primarily addressed to the single author development of the code. Now, we will also use an additional software which is called GitHub Classroom, and that's essentially a collection of scripts that allow me to easily distribute assignments and some pre-made code for you to look at and to work with. I guess the most important thing here is that you have to turn your work in by making commits and pushing your commits to the server. The assignments in the classroom are simply given with a link. So I will be posting links on the course webpage that you just follow, and with your registration on Git, you will be put through to the assignment as well. The repository to complete your assignment will be created automatically, and so this really is a nice system which streamlines the process quite well. Now let's talk about Jupyter Notebooks. Jupyter Notebooks is part of the Anaconda distribution, and this is a tool that allows you to present code together with some math or discussion and description of the code. So this is an excellent way to present and discuss the code. It's also a good place to develop your ideas and work on the mock-ups and prototypes of the coding projects or software projects that you may have. The Jupyter Notebook is a text file, which is a JSON file with multiple sections. It contains and combines different sections with text, math, and formulas and code, and also the output of the code. So I'm using Jupyter Notebooks for these lectures, and here how they look. Right, so it's a collection of sections that you see in your browser, and then I'm making slides out of this. But we will also look at some notebooks which are just looked like that. So here are my slides, right? In the text editor, you would see that these notebooks, they look something like that. So this is a JSON file that has the notebook that we are seeing here. So for example, Jupyter Notebooks, here's the slide. Here's the slide, which is this one, which can be also seen like this. Right, so they also have some limitations. They're not very good way to store a developed piece of code, which may be large. So you don't want all this information around the code. to be stored. You rather have your code to contain just your file just containing the code itself. They're not very good for version control. So as we see the differences in files like here, we would see lots of lines being changed just because some code was run and Jupyter Notebook has recorded that. So this is inconvenient, but not a terrible problem, because you can see still the changes. I will be able to see the changes that you make in the code sections of the notebook. But this is something to be aware of. Now, merging changed files together will most likely break the JSON format of the file, and that's a real problem. So collaborating on Jupyter Notebooks requires some additional tools, which are available, for example, here. But otherwise, this is a really nice tool that we will be using. So let's conclude this session by working through the exercise number 2, which offers us to clone the course repository. This is the repository where the slides for all the lectures will be committed to. I'm going to do it not using my own browser, but using a guest browser. Oh, there are some files already open here. Some locations. Let's start from scratch. Let's just search for GitHub and then econ 3127-4414-8014, which is the code for the course. You can see it turns up a bunch of different search results, including some solutions, but these are the repositories that you don't have access to. But go to the first link here. This is the class organization. This is where all our work related to GitHub will take place. And you can see there is the repository called Lectures 2020 S2. So this is the repository with all the notebooks which are needed for the lectures. You can see it has one commit. This is week 1. And so what we want to do, we want to clone the repository. You have an option of using HTTPS or using or something else. Interesting, not anymore. Open with the GitHub Desktop. I think that's the one that is useful. Okay, it didn't work for me, but I can still copy this link here and go to my GitHub Desktop directly and say File, Clone Repository. That's what I want to do. I want to clone from URL. And here again, it's important to note where this repository will be stored on your local machine. This is going to be in Documents, GitHub Lectures. Okay, clone. This repository will clone now to your local machine. There are no local changes, but you can see history of this repository. And in order to access it, we need to find this directory on our computer. So remember, it was in Documents, GitHub Lectures. So there it is. There it is. The next step, in order to see these notebooks, let's see what's the next step is. Run lecture notebook locally. That's what we're trying to do. So we want to run this notebook on your own computer. So you have to run it on your own computer, and there are several ways to do it. Let's start with Anaconda Navigator. Here we need the Jupyter Notebook. We launch that, and you can see it opens some terminal and starts it. And then it shows us some files. So what actually happens is that in this terminal here, Jupyter Notebook starts a web server, the web server that runs on your local machine. And that allows your browser to talk to your local web server to present these pages. The web server in the background starts Python and starts all the necessary programs. You can see that it opened this server in a particular directory, and I believe this is the home directory of the user. We need to be able to find where the notebooks are. Remember, they were in Documents, GitHub, Lectures. This is where they were. that might be a bit of a problem, especially if you use if you didn't clone the repository in the right location. So what's the other way to open this? Let me close this Jupyter Notebook. The other way is, of course, using the terminal yourself. First, you want to go to the location where the repository was cloned. So GitHub lectures. This is where the notebooks are. And now I want to open a Jupyter Notebook from this location. I have an alias set up for this, and the alias is called Jupyter. But you can see what needs to be typed. You have to say Jupyter Notebook dir and give it the current directory. So this will start Jupyter Notebook in the directory where you wrote it, and therefore we immediately see these files. Okay, we've done number 2. Observe and commit changes. Okay, we need to run the notebook. So let's look at the introductory slides, the introduction lecture that I hope you've already seen. See, it opened for me immediately in the presentation mode. Doesn't have to be the same for you. And here are all the slides and text that you've seen. So imagine that you wanted to make some notes for a lecture. Let's make some notes for this exercise. How can that be done? Well, you can insert a cell, say cell below, make it a markdown and write some notes. Or maybe you had a cell which is a code cell, and you wrote some code really quick. I don't know. And created some variable, gave it a value, and then printed the value. Running the code is Shift-Enter. So here's some output from the code. Okay. So now we want to save this notebook and go back to the version control, to the GitHub Desktop, to see whether there is something that changed. And indeed, see, the 02 workspace IP Y and B, this notebook changed, and we can see that there are new lines here. The new lines that define the cell markdown with some notes, and then another cell which has some code. There's the code, and there's the output. Okay, so this is how little changes may be displayed in the Git diff, which is not super convenient for the Jupyter notebooks. It's not just simple lines that we've added. So maybe these are the notes that you want to save for the for this particular lecture. So how do we do that? Well, we have to commit notes. I could commit this. Okay. And the history is now has this additional thing added, additional commit. Now, pull to check if new lecture materials have become available. You have this repository locally in this directory in your documents, which has all of the lecture slides. And then, next week I've added new lecture slides there. Let's see how that would work. So first, to emulate that, let me make a change in the lecture slide here. Observe and commit changes if you want to save them for later. So this is now the change to the lecture slides, and in my own source tree, in my own Git system, I should see these changes, and here they are. You can see that this line changed in this particular cell. Let me commit these changes. So it's done a little bit differently in source tree, but not really differently, kind of the same. Commit. And now I can push these changes up to the origin, which in my case is the repository for the lectures themselves. If you would try to commit the changes, and let's do that. If you would try to commit the changes, this changes wouldn't go through. GitHub wouldn't allow you to push into the origin changes, into the lecture changes. Now, the last step in the exercise was pull to check if new lecture materials have become available. So let's try to fetch at least, or pull. So here's the minor change, minor update that had become available on GitHub, and you just pull this small update from the server. And this is essentially how you would get the new lecture slides next week. Okay, I think we've done enough today. We can stop here. As always, there are further learning resources. In particular, I would recommend the simple guide to Git, which teaches you various commands that Git system has. You can also follow this tutorial on Jupyter Notebooks, which is very handy to make you more accustomed to working in Jupyter Notebooks. All right, I leave you with that.